Good morning. Okay, we got some stuff to look at this morning. This sweep has 1,200 runs. Yeah? Ooh. 585 runs above 825 score. To 845 is our threshold. We have a lot of good runs here. That is pretty encouraging. That is a sub 5. Holy crap. Okay. Well, I think we win, guys. I think we just win. Brachio. So we have our own locals. Oh, this is Hugging Faces. Is this based on TensorBoard? Usually Hugging Faces engineering is not great. So, Adrian, have you seen Constellation? I made this. Has like instantaneous perf, thousands of points. It's in C. It runs local. It can run on web. I need to polish it up a little bit so it looks a little cleaner. But yeah, this is what we have. That looks epic. Yeah. If we're gonna consider 850 the basically solved threshold, guys, we have a 4.2 second solve. That is absurd. Okay. Well, I guess it works. How's 4.2 seconds sound to solve breakout? Now, we don't know if this repros, right? Like, sometimes these get lucky, but I think we definitely have, we've got a 5 or 6 second for sure. And we can see kind of on the elbow here that, like, yeah, it's about 6 seconds for these tons of stable solves. And this full solves. I mean, this is still, like, absurd. For context, the previous soda was right here. So all of our runs are now better than the previous soda in Puffer 3. Okay, cool. Let me grab one thing, be right back, and I will think about what the hell to do about all this. This is nuts. Look at this. Look at this result. Holy crap. I mean, let's get this into Constellation real quick. Hey Jess, yeah, I'm trying to get some stuff cranking because I'm not streaming all day today. After like maybe 1 or 2 p.m., I gotta start on some client stuff. What have you missed? Sub 5-second breakout solves. When I started this update, it was like, haha, maybe we can solve breakout in 10 seconds, but probably not. And now we're at 5. That's ridiculous. $61 Pareto points from all this data is what we get. Ooh, look at that. So Constellation, the preprocessor just grabs the Pareto optimal points. Wait, what? Oh. That's 800 score in 3.5 seconds. 3.79 for 850. Holy, look at this. 3.79 seconds. 852. How many steps is this? How is that 340 million steps in 3 seconds? That doesn't make sense. Let's go see what on earth is happening with that. Actually, wait, no. This one has to stay here. Okay. Really? It's just big mini batch. I think we need to copy like all the params because I don't think this is covering everything. See if I can find it though. This is 45759. what did we say this one was scoring? $852. I think it's this one. Yes, it's this one. Num layers is 3.5. That's funny. Frame skip is 5. Lovely. No CUDA device. Okay, well that doesn't train at all, so something must be different between these two. Did I miss some keys? Wait, huh? Why does the learning rate match? But the betas are totally different. Oh, because they're missing. Where's beta? Wait, hung up? Huh? I'm so confused. Yeah, it's like completely off. Oh, you know what it is? I know what it is. I'm just recording. There are a few of the variables that get subtracted. That you get like 1 minus. They get recorded as 1 minus, and then they don't get written out back correctly. That's fine. Still no, huh? Probably the alpha. Yeah, look at this. Prio alpha. That'll mess it up. Okay, so that works, but that is a 7-second solve. So how does this say that it's done in... Oh, because it's only 68 mil steps. So wait, how is this? This is supposed to solve in 50 mil? I think we just got lucky, no? That's actually really close. Yeah, you see there's a bit of variance on the EP returns. Hang on. I bet we're doing some weird thing. I bet that we are losing out on eval perf, right? I bet, hang on, let's try something. So there is some genuine variance. To 848. Would be nice if we had this stuff all deterministic. Maybe possible. Actually, probably should be now. I mean, that's definitely good and stable. So what do we do about this? Because we are definitely losing some perf on evals. Oops. I mean, the params work though. I'm surprised it really didn't do anything crazy. Well, did it actually? Hang on, let's check before I say that. No clipping. I forget if this is full prio or prio disabled. I'll have to check that. Lambda's super low. I mean, this is like a good step in the right direction though. Let's go fix up. Let's go fix up a couple of things. I want to check a few things. Six. So 3.5 hours? About 4 hours per sweep. 300 experiments per hour. Hey, Muffin. We solve breakout in 5 seconds now. Less if we're lucky. Look at this graph. Actually, let's not look at this graph. This graph is ugly. Let's look at this graph. Yeah? This is realistically, this is the best one here. 3.79 seconds. There's a little bit of seed variance. But like, it's nowhere near the old RL's totally cursed and jank. It's like, maybe I have to run it for plus or minus a couple seconds. It's pretty cool. Jung said he'll stop by as well to check on sweep stuff. This totally works, though. Oh, it's so close to being there, right? Like, okay. Let's make the plan for today. So I've got like 4 or 5 hours tops to stream today. Because I got some client work to start on. We signed a big contract we've been working on for a while. So we've got some business, which is good, but I have less time to stream, which is what it is. I think I would like to clean up. I'd like to clean up a couple things with Constellation so it's easier to repro runs. That should not take very long at all. We're going to make sure that the configs for the sweeps are good. We're going to make this commit before I break anything as well. So I know how fiddly sweeps are. We'll launch some new experiments. And if I get all that done, then if I get all of that stuff done, then I'll start cleaning up poor Puffer. Constellation. So it's not exactly new Muffin. This was the first thing I worked on for Puffer 4. Like I don't know, I probably spent a month, not on that UI. I spent like a month checking out different things we could look at with sweeps and whatnot. And then a couple weeks building this nice interface and dashboard once I figured out what needed to be vizzed. So it just needs to be cleaned up for release pretty much. This is going to be a major part, though, of the release, is having this dashboard, because this thing is in C. It's super fast. You can load however much data you want into it, and you can even run it on web. It's pretty cool. All right, let's go figure out constellation things, yeah? Yeah. No, you're Muffin. I had to. I had to, right? Constellation's about 1,500 lines of C at the moment. I did clean it up somewhat. It's still pretty messy, but it's better than it would have been. It's just like a whole big block of procedural C that does all the rendering. It's actually not that tough to get like reaccustomed to in some sense, because you just read it top to bottom and you understand what's going on. There's not like very much structure or anything to it. So very nice work. That's good. The one thing that I spent like a few extra hours on that was kind of silly, but I'm kind of happy I did, is the shader that does like the twinkling star effect. It's constellation, you know? What data is it showing? Breakout solve. So you have cost in seconds, you have score. You can also do agent step, which is taking into account frame rate. Was it frame skip rate? And then what's this? The lowest is 140 mil. Yeah, 140 mil. Of course, we're not optimizing for low step solve. If we were to optimize for this, it would go way down. But yeah, you've got cost, you've got score. You can also do like, where is it? Gamma versus score. It does this inverse transform thing for gamma. I don't know if I want to keep that. Lambda. It's pretty cool. I don't think it's not a full replacement in some sense because it's not meant for monitoring runs. So if you have like one long run you want to monitor, it's not great for that. And it also, at the least at the moment, it doesn't plot curves. It's mostly for aggregate monitoring. So if you're going to run a sweep and you want fast stats on a sweep, then this thing will be way faster and easier than WannaBe. I could also make this work for web very easily. No, I could basically make it so that you just drag and drop your data file from your sweep and to your browser, and it's very compact in the format that we have, and it'll just plot everything. I'm gonna do that. Right, so I think what I did is protein. Yeah, exactly. The thing that's a little sketchy at the moment, right? So I have like this is gamma, and I did 1 minus gamma because now you can do log x, right? You can like log transform the x-axis. Another one would be like what, like entropy? Yes, you can like log transform the x-axis here. You can't really log the x-axis otherwise, right? Hmm. Hang on, folks. I've got analysis paralysis here. I'm trying to think if I want to spend my morning. Okay, so here's the one issue at the moment. I don't want to mentally get myself too far off of the cleanup work for the C++. And I think that if I spend my morning like doing the stuff for Constellation to fully fix the copy feature and fix like that, I think it will do that. So I think I'm going to have Constellation be the way it is, and I'm going to work on cleaning up PufferLib. And then Constellation is totally fine. You can use it right now. The only thing will be that the copy feature, a couple of the parameters that get copied get like 1 minus transformed. Like gamma gets 1 minus transformed and stuff. So like you have to edit a couple things. It doesn't fully work because when I do this, it copies the run to my clipboard, all the hypers. So it makes it super easy in theory to repro runs. But I have a couple bugs, and those bugs are actually, now that I'm thinking about it, I'm going to have to redesign a couple things a little bit. So we'll save that. We'll commit the current sweep stuff. I'll clean things up in the puffer sweeps today a little bit, and mainly in the puffer C++. UI looks good. It looks way cooler when you have multiple different environments because it'll use different colors for different ends. And like you can filter all environments so you can overlap them. And then this will give you hyperparam sensitivity across ends. You get like this cool plot here, the 3D plot across ends. It looks really sweet. This is also like big props to Kyung for the work that he did on follow-ups to Protein. So a lot of the like pruning bad runs, that stuff was all Kyung. So I made the base protein algorithm, but like the thing that prevents it from wasting a ton of compute, that's Kyung's work. And it's non-trivial as well. Okay, so first thing, let's figure out what I want to do about this want be logger thing. Yeah, he posts some stuff on X. He does mostly robotics, but he's done a lot of RL with us over the last few years. Oh, I forgot that I had on. Okay, yeah, Kyung, right here, KYWCH 500. Oh, Kyung also did 2048 lately. He's done a bunch of stuff. This is Superhuman on 2048. I'm just trying to figure out how I want to do the logger. Um, does this need a log thing, actually? Load policy. I think we'll keep the logger thing, but let's just do... Let's just do train config. So this just becomes args. That seems weird. Datadir. Mm-hmm. Let's do it this way. We're just going to clean up and fuse the logger together so it's nice and clean. It's just, we'll make one be optional. We don't really need to have a ton of different backends for it. For context, guys, we are dropping Neptune support in Puffer 4 because OpenAI bought it and killed it. You know, OpenAI bought and killed the like free logging thing. Just so we're clear on that that dynamic, you know. join. I see. Cool. That's solid. Do we run? Let's just try sweep super quick. Okay, next thing. Yeah, next thing. There were two features missing. There were two features missing. Let me see how this works. So it's just like DDP policy. How does DDP work? Does it hook into anything that is an optimizer, I wonder? Entirely on the model side. Works on dot backward. Oh, okay, cool. So then it should just work. Wait, can I not just like... I think I can just do it with this. Hey Xantos, welcome. Let's go find, I have it in my docs, right? The distributed. It's just torch run, yeah? I figure we may as well, because there are only like two features left, I think, that we need for the release. One is DDP and the other is continuous action space support. I think that's all we're missing. Okay. Policy. Because we do not have load policy, right? So just go down here, maybe? Oh, I see. So this doesn't really fit here, does it? But hang on. Maybe it's easy. What's DDP do? X precision, we don't need that. Because that's their mixed precision, DDP sync, DDP join hook. How hard is this? I do have CUDA graphs. Static. Okay, so most of this crap is for things we don't use, as usual. Detach, broadcast coalesced. Plus DDP backward. It is literally. Oh shoot, I'm graphing the optimizer. Oh, crap. That's tough. Yeah, shoot, I'm graphing the optimizer. That's really bad. I totally forgot about that. Ooh, interesting. Wait, isn't this really easy then? Wait, I think this is really easy. Oops. New Claude models? No. I'm excited to get my code base into a spot where it's less required to use these stupid models. I think it is just about this simple. Right, because we can't use torch run. You want to all reduce the entire gradient buffer in one call rather than per parameter. True. This actually could be made so much faster than torches. Holy shit. If we do this. Hang on though, I have to figure out. Ooh, wait a second. We can just do, yeah, this is easy. No, actually, this is really, really good. Hang on. Let me just commit real, let's just, I don't actually feel too bad about using, like, because essentially this is using Claude to clean up Torch's mess, right? But let me just figure out one thing. So we actually, the way the vec works is pretty clean for this already. End processes or use threads with CUDA visible devices. Rank 0 generates NCCL unique ID. Pomegranate, if you're new around here, so my workflow is not really heavily AI. In fact, so I've only really been using this stuff in the last few weeks. I hate it. I think it's generally awful. This project specifically, I'm essentially ripping out chunks of Torch bit by bit and replacing them with much simpler and faster raw CUDA and C. So none of this stuff in Torch is documented. It's very difficult to sort of do this chunk. But the goal of what I'm doing here is ultimately we're going to get something that's very short, very simple, very easy for people to edit without needing to heavily rely on these models. Um, but it's going to take some work in the process. I'm not really looking to adopt a heavier AI workflow. I generally think it's the wrong direction for engineering. We need people thinking about problems more deeply and at a lower level. And the heavy AI workflow pushes people towards higher level, not thinking concretely about the details of the problem that actually matter. So to kind of narrate my thought process here, right? We kind of already have Puffer so that we are collecting experience independently on a bunch of different CUDA streams. And the environments also all have their own processes. So that could very easily be altered to just like pin one of those or multiple of those to each GPU. That should be pretty straightforward. They are writing to the same buffer. I don't know if Torch does any weird locking crap. I don't think so. So I think actually the eval loop should be pretty easy to scale to multi-GPU, which is really nice. Now the train loop, on the other hand, is a bit harder because with the train loop, first of all, it's not fully CUDA graphed. So it's like not easy to split that into work for different GPUs. Essentially, actually, all that gives you as well, hang on, that gives you bigger mini batches, right? Yeah, because you reduce gradients. That's actually not amazing if we think about it, right? Because what does this give you? So the original way that we did DDP in Puffer 3 was just the torch wrapper. And all that that does is you run an all reduce when you collect gradients. So that lets you use bigger batch sizes. That's not super helpful on its own, is it? That's not super helpful on its own. All right, I gotta use the restroom. Let me be back in a few minutes here, and we'll figure out how to do this. The forward pass is gonna rock. I think the forward pass we are going to like get perfect speed up, and it's going to be awesome. I don't know about the backward yet. I'll be back. So I thought about it a little bit. Um, there's a simple way to do this and a complicated way to do this. The complicated way is ultimately going to end up being simpler, but I don't think it's the right move while we still have torch in the mix. So, because basically we can either just on the outer loop launch a bunch of processes and add an all reduce and be done, or we can essentially redesign the entire thing to like manage all the processes. I think that second one's going to be better long term, but this is not the time to add it because one, it'll take quite a while to do that, and two, it's not going to play nice with torch. So I think that's what we do in a couple of updates in the future. Uh, Hang on. I think that works. So we basically just make our own way easier torch run. Yeah. Via file, the hell? It's right here. Right? No, here. It's after we compute all updates. Zero's like weight buffer. Zeroth power via Newton-Scholes. Yeah, so right here. This still has to get done on one GPU, which is annoying. It's the same speed though. momentum buffer. Rank, path, yeah. So then train multi-GPU, train rank, and then this calls train. This is not quite correct. No, it is. It's none. Okay, we'll have to change it so to like not log if there's no logger, I suppose. All grads. Yeah, so we have this. After grad collection, you do this, yes. Okay, this is literally 50 lines. Let's make the change. This is not the best way of doing it. Let's be clear. I think that this will be much faster than Torches, though. And also Torches is not compatible anyways. Because I looked at Torch, it has a whole bunch of crap. Multi-GPU gradient. On the current stream as well. And then this should just get graphed. This NCCL pathing is weird. Fine. Hang on, what's this? Set device. I think this is okay. And this is fine. And this is fine. This is easy enough. I'm trying to think what can go wrong with this. I guess like CUDA graphing. The only thing I can see messing up with this is CUDA graphing being jank. Oh yeah, we should also probably just keep the top one on the main process. Single GPU. What the heck? Don't use this pattern. So don't let it do this. It's fine. New fields is fine. Default config. Yes. Rank 0. Multi-GPU launcher. Is there any reason put this? Okay, so now we have rank 0 will go on the main process. Okay. Not perfect code, but pretty close. I'll have to clean it up a little bit. If this adds 100 lines for multi-GPU, and actually we'll get to delete some of the old torch jank from this as well. Like all the disk gather stuff on logs we'll get to delete. Let's see if we can fake it on 1 GPU. Okay, so we don't actually know whether this does anything is the problem. Since this is just on rank 1. I don't think we need to do it that way. Yeah, actually, sure. We'll just undo it after a quick test. Because I don't think it's doing... I actually don't know if it's doing the all reduce right now. I would think it probably isn't. Because the world size is 1. Python handles it directly. Fine. That's a little jank. I mean, hopefully this should not... This really should not be that complicated. It's kind of funny. Yeah. And I guess the way that we test this is if I just do buffer max 1, launch NVIDIA. So this should give us 4 sub-processes, right? Oops. Nope. I think I am, unfortunately, I'm going to have to set this up on one of the multi-GPU boxes to test this. Oh, wait. No, hang on. I think I'm just dumb and did it wrong. You. Num GPUs. Yeah, that's not good. device. Initialized in the parent before forking, yes. Required. Okay, that's annoying to set this to spawn. The reason this is annoying is spawn takes like way longer to start up. Each process will think it only has to size 0, but they're in difficult physical devices. We need to set device and each child starts fresh. Yes, that is a problem. Zero on main process, and then with spawn, yes, okay. Am I crazy for thinking that this is just gonna get to be like way, way, way easier? As soon as we don't have like Torch and Python in the loop? I don't think that's crazy. I think it's gonna just be way easier. Yeah, okay, so this is just the test logic failing. Oh, okay, fake GPUs is true, fine. Forgot the flag, no biggie. Okay. So, presumably the stats here are wrong, right? This does run. Is there any way around the fact that we're getting a quarter of the log data? Not an easy one. I think this is about the limit of what we should be doing with Claude. The rest should be me. So, Yeah, so here's what we're gonna do. Use equals 4, 1. Streaming on any category. So here's the annoying thing, and I gotta switch my stream software. I gotta take some time to do this at some point. There's not a way for me to set my stream category on Twitch from Restream. I mean, realistically, I just have to get a day where I'm not like exhausted from all the stuff I've been working on and just like spend some time doing some admin stuff, fixing up stream, doing all the other little things I ignore. Where's train logic? Here. Right? Okay, lovely. So we get to just delete this entirely. Get to delete this entirely. And then what we do train args rank, env name rank world size, and CCL ID path. Rank is 0. OS get PID. Oh, because it's using this load config env name. Because it's a multi-process thing, yeah. No, I see why it's done this way, it's fine. Wait, no, you can pass dictionaries. I think this is fine. GPUs, fake GPUs. So we can just do this as world size. logger equals none. Yeah, we can merge all this crap, can't we? So like this can go here. And then this takes actually I see why it's like this. Name none. Backend policy, this stuff does not get passed anymore. Logger none true. Okay. Because basically the thing here is this function now does everything. And then all we have to do here, so this is train rank. And then this is just train, which can take same sig pretty much, right? These can go at the top, because why not? Logger is going to be none. Rank 0 on main process. Oh no, that is a problem, because it'll make... Hang on. Yeah, this is weird. This is train rank. This is train. You know, it's kind of funny where all these things that are supposed to be super difficult in Magic are only super difficult in Magic because of garbage engineering. Like, you basically just need one low-level primitive, which is an all reduce, and like it's kind of trivial on top of that. Like the whole stack of other crap is like what on earth? Obviously with big models there's more engineering, but the fact that just the entry point to doing anything is so high is ridiculous. There's no need for it. Okay, where is my thingy? Train, puffer. There you go. Not. Point. rank args is none. Oh, name worker args. Yeah, something like this, right? Go away, Claude. Like, come on, we don't need Claude for this crap. This is like, it's so tempting to overuse it. Stupid thing. Alright, look at that. So that now runs. Ooh. There are a few changes we need, right? Yeah, so we sort of have to divide up the mini batches and stuff. Oh, you don't have, wait, you do have this, right? Yes, I might, yeah, this is fine. So, mini batch size gets divided, vec num n, no, it's total agents, that's it, right? Yeah. And then I believe we pass logger. Let's get rid of dist sum. Dist mean, we don't need this shit anymore. Self.global step times config GPUs. Then SPS is likewise int SPS times GPUs int that's fine, right? I think that's it. This is now gone. Okay. Still slow. None type object. No attribute run ID. Oop. Close. If not self. And I think a little bit more of this can get moved out as well. Yeah, and then the rest of this is just me having to move stuff out of the log. Right? Cool. Yeah, the rest is me just having to move stuff out of here. Evaluate does not get merged. So we can just put this, I think it's literally as simple as doing this. Train rank, join. And then we just do the final eval. Turn. And then let's give this thing a logger. Do we ever do anything with all logs? We don't, right? I just do this for now. Yeah, the eval's actually going to be kind of bad. Come to think of it. This maybe. Yeah, all the time going into eval as well means we probably just have way too many buffers. Too many cores. Why is this hanging? C.profiler.stop. Print. Done. Okay, so we get all these done. Done, done, done. Figure out what the hell's going on here. Interesting. So this one should be done, right? Train rank. So it's got to be stuck on the join. Oh, does it not have the close in it? Yeah, it doesn't have the close. I'm dumb. Hang on. Actually, maybe this is better. Close. Let's just do like this, right? Worker args, worker args. We'll clean this up, don't worry. Crane like this. And then, so this is now final eval. And now we have made this thing. And just makes a new one. Final eval, is it stuck here? It appears to be stuck here. I don't know what it would be stuck on though. Really? Oh, actually we don't want to do this final eval like this, right? Yeah, we do actually just want to use the train perf. Okay. I remembered why. Yeah, this is going to be jank. We tried this before. This is super jank. You have to evaluate way longer if you do it this way. if not logger. Just some shenanigans. This is not a bad thing to be doing today, though. Multi-GPU is a really big feature. It's not that difficult, actually. It really isn't. Let me go grab myself a mug of tea and we'll continue, alright? I'll be back in a few. All right. Give me 1 second and we'll fix this. Yep. All right. So, um, we got this actually working, which is pretty good. I guess technically there could be some bugs when we actually go to use multiple devices, but probably is okay. It's pretty simple. Invoked with none. So logger. The nice thing with Puffer Constellation is you don't even screw up your logs by having bad runs in there, because it just filters out to Pareto points anyways. Okay, that's clean. That is clean. It is actually slightly worse perf-wise. Advantages are going to be calc'd different. We can fix that. It's not hard. And we can fix that. What do we think about this? This is good. I think it's good. Now, we do have this num threads problem thing, right? Yeah, num thread 16. That's a Claude refactor. Yeah, because basically this num thread has to get split. And presumably you're using one thread per core. Okay. Well, we wanted to be able to sweep this thing potentially anyways. So real quick, we can try dividing threads by GPUs. Don't know if that's quite how we want to do it. I think we can just do with args threads. Buffer. I think num buffers is it 4? That's 2. 2 buffers should be okay. That's substantially better, right? A little worse in training though. It's not num GPUs. Train.gpu is 1. Yeah, so that is better. So there is a slight difference. It's probably the advantage function. Or are we still fast? Hang on, are we still fast? Yeah, we're still fast. We're not expecting this to be faster, keep in mind. So this is a 1 GPU machine. Yeah, so this is basically just setting shitty args. Okay. We're good. I think this is fine. Fake GPUs. If not fake GPUs. There. And when we call train, if it's none, log it's this. So presumably this should still be logging stuff, yes? Okay, so I mean, we'll have to test this multi-GPU, but this is pretty much fine. I think we can leave this alone, right? All right, I'm happy with this. I think this is a decent chunk of stuff to commit. Okay. So I mean, there's some like little design decisions that are easy enough to make, but that is one of two remaining features that we had not implemented. Now the other one we want to have is continuous. I see. So what's this do? Do we have normal distribution? Oh, this is very jank actually. Distributions.normal. And what we do, if it's none, then you sample. Otherwise, you do .log prob. If How difficult is that? That is kind of annoying, right? Because now the value function has mean and standard deviation. This is another Claude thing, but it's not a stupid Claude thing. This is like I don't autopilot this. So this is going to be hang on. Is it? Wait. You add no, it's not that hard, right? No, because you just get the mean and then the log standard deviation is not learned. Oops. Why is my T not T'ing? That's a sentence. Not brute at all. There we go. Got a minute. Okay, so this is just like you add log standard dev. The output kernel will have a different shape. Oh, this actually makes it easy for us to do mixed, continuous, and discrete, which is pretty cool, I think. Yes, it does. Okay, I think I can actually just have Claude do this if I'm very precise about exactly. Because I think I have the rough outline in my head, but this is not enough. I need to know exactly what this should look like. So it's going to just be if the action size is 1, you assume it's continuous. You just assert that they're all either zeros or ones or not. If they're continuous, you add the decoder like this. And the forward pass is almost the same. You have to add this log std in. Okay, it's kind of a pain, but I'm at least confident we can do this without breaking it. I think this is the last major thing, though, that I need to have plot for. Maybe some still refactors, actually. And there's just so much torch crap. Like, this would be so simple in C, or in just C CUDA C. The same, actually. Wait, is this needed for, hang on, let me make sure I get this correct. Yeah, you don't need the sample. Digits. What is the log prob of a normal distribution? Like this, right? Okay. I think that's precise enough to prevent stupid shit. Man, there's going to be so much manual cleanup for this update. Are there any other features I'm forgetting? Continuous support. I think there's some bindings to be exposed and stuff, but other than that, I think that would be feature complete. Continuous action support. Multi-GPU. Constellation. I think it's feature complete and we just need to clean stuff up for the most part. A few default networks haven't been ported. So that would be nice. I got about like 2-ish hours to stream before I got to go work on client stuff, I think, now. So hopefully we have this done. We'll be able to test this by just training the drone env. Use them. No. The agents that we are training are like tiny superhuman models. They run at millions of they run at millions of steps per second. It's a totally different world. Does this need a continuous decoder? Mean linear. Does this need to be a separate decoder? It probably does, right? That's annoying, though, to have that. Let's just say one decoder. Yeah. So we keep one decoder. We deal with the potentially undefined log probs item if we need to. Or was it log standard deviation item? This adds a little bit to the sample path in torch and the loss path in torch. What the hell is it doing? Okay, let's see what this is. This cat is bad. Right? Yeah, that's a real mess to handle. Let me think, is there a better way? I don't like that. No, I don't like that at all. Cat's slow. You can't just throw in random torch obs. See, this is why torch is bad. It's just like, oh yeah, we can just concat it and then return it for convenience. It's like, no, that's not how computer works. Fine, whatever, we can do this. Yeah, so these encoders are now going to be stupid, but we can do it this way for now. At the very least, I don't think we've broken anything yet. Fine. Yeah, see, this is going to have cascading annoying shit just to handle continuous. I don't know how much we even care about the, well, I guess we need it for now. This is fun. Okay, so now this is where things can go bad. This is where things can go bad. If it's continuous, no. It's got to be one kernel. Let's see what's done. Logits. This is fine. It just added one. Yep. Okay, and then this is what, 317? If it's continuous, yep. This block here, right? This is fine. can be simplified, but it's fine. It's continuous. This is the module def. Okay. UPass is continuous. This is a find launch function update. I mean the find module update. Very small header update. This is why the models are basically mandatory here, you see? Like the amount of redundant crap. Look, there's another one. Oh, geez. Okay. Okay, this just adds log std. And is continuous. To pi. Courant normal. And state. Uh-oh. Let me go look at this. Let me see how we're using our noise. Courant uniform. Okay, this is actually okay, I think. This is log prob. Entropy is not calced here. Entropy is not calced here. Discrete sampling should be the same. Yeah, so this looks like a big scary diff, but it's just the diff tool being shitty. You're gonna see, watch what happens when I hit yes here. There's all our code from before. There's the new path. Not bad, right? And this won't slow anything down because this path will never get triggered. So there's actually no branching. It could only ever be one path. So at the very least, this should not screw up our discrete training, and I think it's likely this will be correct for continuous. Now, I am still worried about two things. I'm somewhat worried about the strides. Though actually, the way that this is done, I think it's not too bad. I think this is like actually pretty simple for strides. And then the other thing is going to be the loss kernel. Because the loss kernel basically has to do the same thing. Yeah. Hey, don't worry. I'm not shipping like 8,000 lines of garbage. We will have to clean all this stuff up. It's a bit annoying though. Silly. Okay, yeah, so that did update. I don't know if it updated the launch functions, did it? It did. Yeah, that updated loss function. Yeah, this is fine. Both continuous and discrete. Okay, eh? Wait, int star. Okay, this is actually fine. I think this is fine. Yeah, so it's just we're storing all actions as double. That's fine, right? Yeah, that's fine. Okay, so let's actually look at this. So we are adding log standard deviation and we're changing the type. So we're just going to assume that that's going to be cached cleanly, which it will be. Half log pi, yeah. So here we have the same sampling. Oh no, it's the log. Okay. So this is leaving everything else as is, right? Pufferfish playing League of Legends. Could happen. The main thing with that, the main thing with that is that the game itself is slow, right? But probably not that slow, actually. I think of the big games, that would probably be one of the easier ones to throw it at. I mean, we do have this thing, which is our own little MOBA. It's based on Dota. Obviously simplified because I didn't just go re-implement all of Dota. But it's got 5v5, it's got actual creeps, reasonable pathing, like it's got some unique abilities per character, it's got towers, it's got like the key MOBA elements, and this thing you can train like reasonable stuff quite quickly. Okay, let's see. This should just add one path, right? Yeah, so this code is unchanged. And then it's this. Okay, so we'll have to check this math. But this is about what I would expect. Yes. This is sick. Yeah, we have we have a whole bunch of M's, right? I mean, the key thing with Puffer is we can literally train millions of steps per second. In fact, we're at 14 million for some of our M's in this latest dev version. And that's on single GPU. So that for context, like that means if we're just playing something simple like Breakout, it's playing something between 3 and 4 months worth of Breakout games every second of training. It's just an absurd amount of data. What the hell's happening here? Any comment on this? Oh, this is the backward kernel, right? Ooh, yeah, so it's not going to break it because this is the same code being moved down. So I think this is safe because it's just going to give one different path, right? Which is right here for the backwards pass. Okay, it literally just copy pasted the entire code, which is kind of silly. Gradients per head. If this works, it's actually kind of impressive. To be fair, it's trained on like several variations of this exact code, so. Float 64. Okay, this is just the launch function. This is fine. The only thing we have to now be careful is that the buffers in the main training code for actions now need to be double, which is safe because double contains int32 and float. I actually don't know why I didn't do that to begin with. I definitely should have. Now, the one thing that's going to suck is if this math is wrong on continuous, it's not going to be fun because it gets duplicated in several spots. Now, actually, we will be able to test this somewhat because we also have the pure PyTorch pathway. So we will be able to debug this by testing if continuous is stable with the native, not PyTorch, libtorch path. We'll be able to test that. So we do have verifiability on many levels. It's not a significant change. That's a very simple change. Actually, the only complicated piece of this that I'm worried about is the kernel changes. Everything else is just like bloat from Torch. So pretty much the only things that were actually mattering, and we could very easily strip out a few chunks of this into inline functions, and we can make the kernel substantially shorter. In fact, we should probably do that. this the right kernel? Yes. Now the painful thing is if this does work, this will mean that our release is feature complete, but a mess. And we have about 3,000 lines of kernels, I think 2,000 lines of module binds, and 1,500 lines worth of Torch C++, and like 3,000 lines worth of kernel tests. So we have a just huge amount of crap that needs to be cleaned up, which is entirely my fault. Well, mostly my fault. To be fair, a lot of it is just torch bloat, but I think we can at least do a fair bit better than we have it now. Yes. Yes. This is fine. What is going on here? Right, so this is just getting moved. And let's not mess this up. Train forward call. Okay, right, so this is just in the non-kernel path. Yeah, this is just the non-kernel path. Discontinuous. Yes. So this adds a whole bunch of crap. A lot of this can be cleaned up. Let's see if we can have it work first. The result is very good. I think what we're gonna end up having to do is like go quantify how much of the bloat is coming from different sources and like what we can cut out. Yeah, so the biggest change is right there. That is the actions going to float 64. I actually don't know why I had them in int64 before though, because they should be. They totally should be. in float 64. Cast actions doubles in the kernel. Yes, so that is the other thing right there, the cast, so that the action type is correct. That is if, so I think that if we broke discrete training, it will be because of that. That is a very easy thing for us to find. Okay. Breakout. Place. Do we build? And it will be, does this build first? Okay, it does. Does it train discrete? Tensor does not have a device. Really? Oh, that could just be the empty tensors or whatever. Train forward call. This one. It's gonna like treat that as a string. Okay, now we get a different error. 958. Train forward call, lovely. Custom function. What the heck would that be? I actually don't know what tensor that would be. It has it in context, though. It's fine. It probably added. But I would probably say like fused. Was it PPO loss? Logits data, values data. Optimized. I see. So it needs to just have the placeholder tensor be on device. Which is fine. That's fine. It's a very minor thing to fix. Just have pass options. And hopefully now we have our discrete training working again. We should not have any sort of speed drop. It does not have a device, really? Same error. A better error message out of this stupid thing. See, we can't get a better error out of this. It's very, very irritating. What we do have, it is in the loss, the optimized loss. It's in the forward function of that. See options. Undefined tensor to empty. Ah. Same. This is just torch jank. There's like nothing really to write home about. It's just torch jank. Okay, it runs. Right? We hit setup. One more time. There's your stupidly fast solve. Yeah? Now we just need a continuous emp to play with. Did we ever do drone? I think so. Segfault, lovely. Num agents. We have vec total agents should be, what's that? 16 by 64. And 64 times what's 8? 16, 64. Oh, it is 8192. So that's totally fine. Agents. We do have num agents, we have max rings. Chess 0 engine. I don't know. This is trained with search, right? Yeah, it's search. So I mean, what we're trying to do is we're explicitly just trying to do chess without search. Alpha 0 but better. That's cool. Embedding CNNs are slow. Yeah. I mean, you can go look at the embeddings that they use, Jess, and see which you can make fast. I don't really care if you have to steal, like, encoders as long as you can get them fast. It's mainly the search chunk is what we want to not have to deal with. Okay, so we have this working. What is the easiest way for us to just figure out real quick? Maybe... we should just be able to, like, stack trace. Okay, so it is in C step. Double actions. Agents. We do have num agents. What's init do? Assigns agents, assigns ring buffer. Doesn't attempt to reset. This is correct. Oh wait, ocean drone binding.h. It's the .h file. Oh, but it's still the same thing. Start thread. Yeah, that's really irritating. What do we do to fix this? Ob size is 26, num actions is 4, right? 26, yes. Num m's to num agents. Did you change num m's to num agents? No. So m's have a num agents, and there's vec total agents now. Terminology subject to change until end of 4.0. Things need to be cleaned up a lot though, Jess. It's just like because the new vec backend, it works a bit differently. Today's float act type is double. Actions is 4. This looks correct to me. Yeah, I don't know, there's just so much stuff to finish, Jess. It's a lot. It's really a lot. Okay, render's not included. This is good. Set. Yeah, Doesn't this get a task? Or does this have all the tasks? This has all the tasks. Num agents. Total agents. Which is our default, so we don't need it actually. Anything else weird we're doing? These are dated. I don't think there's anything else weird. Hmm. Peru said that he got me a nice debug PR, so I'm gonna just go grab that. I'm not signed into this tab. Hang on. Ferocity got me a nice nice debug PR. Oh, okay, that's annoying. That's bigger than I can just do real quick. Breakout. Oh. PG. Hey, user. Okay. Agent state is nan. Mostly nans. How'd that happen? Check collision. Agents. Up. 64 agents. And why does this dude have nan state? That actually looks like a numerical screw up, doesn't it? Just real quick. Let's just make sure it's not some utterly stupid name collision thing. I mean, that would just be embarrassing, right? Did I change this? 30, 30, and 10. I don't remember if I changed this. I don't think I did. Oh, you know what it could totally be, though? It could totally be bad actions. That's probably what it is, in fact, right? Nan. One, two. 9 times 4. Plus 36, 39. Okay, so it's just randomly some actions, Nan. What's this supposed to get clipped to? 1, -1. I'll be right back. Let me use the restroom. Grab more tape. Let me get my tea. Tea everywhere. Let me clean this up. Hope you're good. All right. That should be relatively quick. Yeah, we definitely want action clipping to occur in the policy because we should have it such that you can never give the environment an invalid action. I think that is better than having the environments be responsible for it. Played a blitz game against our chess bot. 4 move ahead tactics and strategic planning. Punish me when I give it a mistake. That's really solid. Play some more games, more seriousness, and report back. Looking forward to embeddings. Elo getting accurate sooner with embeddings for CNN. That is awesome. Hey, this all sounds like good progress, Jess. This all sounds like good progress. Okay, it runs, it doesn't segfault, right? Let's now go sub.py bug. Do we have any other environments that we can use as a quick continuous test? Carpools being jank, I don't want to use that. I mean, we don't have a ton of continuous stuff, do we? I think drone is really the main one. We do use drone continuous, right? Yeah, we do. But this definitely trains in Puffer 3, right? Like, do I have 3 here? What did I change? Because this is a local. Check out. Full. Yeah. It's not particularly fast, and it's also not training correctly. So something's wrong. PufferL. No. Build. Okay. Yeah. 2.3 mil on my local machine, which is substantially worse. And it's basically going to start improving instantly. Yeah, so this starts improving in like a few seconds. And it's very stable. Okay. First of all, why is it slow? Being slow on Puffer 4 is very weird. It's all in the forward pass. Okay. We have coup de grace off. They should be on, but it should still be faster even with coup de grace off. Yeah, see, it's all in this forward. Default num threads. 16 threads. We do have total agents wrong. Wrong. So we can just set vec total agents equals. Okay, so we are still slow. Doesn't make much sense. We shouldn't be end of bound, and even if we are, it shouldn't be this slow. If setup high, no. Build price. Don't have like a weird debug build, right? Huh. We'll definitely have to figure this one out. Now, more importantly though, why is it not even training? It should be training like instantly. It's not. Okay, well we have some stuff we can try, right? False, no kernels. False, no bfloat. Okay, so it's not the kernels. We're not even training in standard here. Could be hyper renaming. Just double check. Nope, I don't see any hypers that would mess with this. It's a little irritating because we do not have confirmation on this end, is the one problem. Okay, here's what we're gonna do. Where can I play the chess bot? We think the chess bot's what, between like 1100 and 1500 at this point? It's in dev. You can probably set up one of the repos for it, like one of their forks. Okay, so we can confirm squared does not train, right? This is kind of what we were afraid of. Hey, Kyung. How's it going? You have gotten us something pretty awesome, man. Check this out. Oops. Where'd Constellation go? Oh. Oh. Yeah, check this out. 3.7 second solve, 3-second near solve. Full vibe coder? No, not at all. Not at all. I'm trying to get this shit out of my workflow. The problem is that we've inherited several thousand lines of jank from Torch, and it's really difficult to edit manually because everything is super redundant. So my goal is to like automated refactor stuff to a point where it's human editable again, and then not have to use the model. Yeah, so Kyung, I had to like update some small things to get it onto 4.0. It looks pretty good now. The one thing I'm not sure is I checked a run like pretty far through, and it didn't look like it was using the robust log cost model. I think it can go even faster. Because like I think it should be able to even go faster than this. I don't know why it would have any experiments out at 30 seconds, frankly, with like a linear cost model. 63. I guess it's like splitting hairs. No, because it's already max score at 864. So it's actually impossible that it got a higher score than this, and it's still running stuff out to here. It's kind of weird. Far fewer yet. Well, this is not all the experiments. So Constellation only grabs Pareto optimal points. These are all the experiments. This is a 1200 run sweep. So with 1200, we would expect it to be very optimized. Opus 4.6. Honestly, I don't really care. So probably this is like the highest quality one, which is a 6.2 second full solve. But then like realistically anything above 850 is basically a solve. So like 4.5 second solve. Actually, this 4.2 second solve, right? Not to go too aggressive. Yeah, I think it's okay in that case. The thing that was weird to me is like the startup runs. But then the only thing I think that you replied that there is a cutoff. Hang on, cost random suggestion. Yeah, so here's the thing that I wasn't sure about, right? So if I understand this correctly from your message here, the first several runs, you're using random parameters, which is fine. But then you're using the cost model to prune out suggestions that should be too long. But like the cost model isn't trained reasonably yet. So it can just be running really obnoxiously long stuff for no reason. Right? So I don't think this is about it being aggressive or not. I think this is like the startup runs are not being clipped appropriately. I'm pretty sure. Obviously, I'm going to have to run more of these sweeps in order to tell. Not prune out, so just set the mean training steps. I don't know what you mean by that. If default training steps is too large, the mean and norm. So the default training step, it runs in like 7 seconds is the thing. But, you know, if you go and you take the default training step and you crank up the network size and you crank down the number of agents, you can very easily sample stuff around that mean that's going to be really slow. You see what I mean? Sweep range. That's the defaults, right? I mean, look, yes, I can limit total time steps. I'm a bit confused though because I thought in the new version we didn't really have to limit the total time steps. I did tighten it, and I think that's one of the reasons that it worked. Yeah, see, I limited it to 2e8 max, so it can't go crazy long, but it's still it's still fairly long. And I mean, you can tell when you start a new run that like it's like kind of it feels bad because you see that it'll run like a 7-second experiment that solves the env, and then it'll go and run a whole bunch of like 20-30 second experiments several times longer that don't learn anything. Cost is determined by sweep range. But by sweep range, you just mean like whatever it happens to sample around the mean, right? In the normalized space. That's a really big range because there are many parameters, right, that influence the cost. It's not just time steps. It can be the model size, the width, the number of layers. Let's talk. Let's do that. That's easier. Let's get Discord. I'm in Gen Chat. You're muted.
Hey, Joseph.
Hey, Kyung, how's it going?
Good. Finally, sweep is happening. Huh?
Yeah, sweeps. It's already improved, right? Like it's taken us down from 7 seconds to like 5 or 6. I think we can get
Nice
some
10x
points.
thing.
Yeah, seriously.
Literally 10xing the speed.
Yeah. Well, I think it can even do better. It's just I'm a little confused. So this is, I think, a little more minor. It's just some pruning stuff. Um,
Mhm.
I I don't know. Some part of me just I think that we can go faster than this, and the reason for that is like it's still running configs that are pretty close to what I started with. I haven't fully looked yet, but like if
Mhm.
I go look at, hang on, Can I go look at like what is this? Mini batch. Let's do vec num total. The one piece UI is so bad.
Now you're replacing it.
Yeah, that's literally why I'm replacing it. It's almost unusable. I mean, I guess it is running. It's running a bunch of experiments. I guess I'm suspecting that it should be able to find some stuff that should be better with like fewer agents and smaller mini batch and stuff maybe
Uh-huh.
because maybe not. I don't know. Like the curve should be better essentially. So Puffer should be scaling better on smaller mini batches and stuff now. Like it should not. You should actually be even faster with that. We also have a bunch of other params. So I want to make sure we're fully sweeping correctly. And I went through some of the sweeps code. The robust log cost model looked good. I didn't know if there was anything else weird going on though, and I want to make sure
So,
that we
so,
have like the full sweep stuff in 4.0. I also it's a little annoying because I don't have all the M's to test with yet, right? So there's still that, but like I'm kind of surprised that we didn't get dramatically different network size or like dramatically different batch or anything out of this.
but breakout is like a swept to death, right?
So
No wonder.
except but like it's different in Puffer 4 because
Ah,
configs that used to be too slow. So for instance, before if you cut the mini batch size in half, it would train like the same speed pretty much because of the
hmm,
overhead. Puffer is so much lower overhead now that there's a very wide range of configs that used to be inefficient that are now efficient.
hmm. So okay, so let's focus on the first runs, first 10 runs. So that's where I set the cost random suggestion. And so I in the Discord I put that like hyperparameter search centers, which we removed from default, but it's the like the mean
Yeah.
uh the search center is the like a zero in like a -1
Mm-hmm.
to 1 normed space, right?
Yeah.
So when training steps is like that like 10 billion, the max is 10 billion, the minimum is like let's say 100 million, then the mean in the normed space will be like billion ish, right? So 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 that's where like when we
Yeah.
use the search center for the first 10
Oh.
runs, that's where like the first 10 runs will get like pretty long, like unnecessarily.
Yeah.
So that's why I suggested probably instead of search center, let's set it to minus zero point 0.5 or like 0.7 ish. So how the
Hmm.
sweep
Why
is
can't we just use
bootstrap.
the log? Like, we can't just use the. I guess we can't just use the log cost model on the default. No?
So log cost model also needs some data to run, right? So like the first few suggestion will be jank.
Hmm. Can we not get like any sort of reasonable bound out of it? Because it's like here, it's pretty silly that we see. Look, so if I change this to be created time step and score. Okay, I can't actually tell where I started the sweep. Oh, I see what's wrong. It's because I have it filtered to only the good runs. Okay, so now they're 1200 points, and now Wannabe is totally gonna just die. Okay, if I do created timestamp, because I remember basically seeing that, yeah, there are a bunch of like bad runs early, obviously, but then if we look at the created timestamp versus uptime, I think they spend quite a while. Yeah, like there are a lot of these early runs that don't do well that are like 3 or 4 times longer than the initial run. And presumably, right, if I set the range even longer, Like these runs could be very long.
Yeah. So that's where I think just lowering the cost random suggestion to like minus 0.5 or minus 0.7.
The
Oh,
cost
oh,
random, wait, the cost random suggestion.
so yeah, I put that on the like snippet on Discord,
Yeah,
right?
I
So
don't understand this code because this is using the cost model, right?
no, it's not. For first 10 runs, it's not.
Then how is it estimating it?
It's not estimating it.
Wait, suggestion of cost random suggestion. Yeah, I don't understand how this works then. Um, yeah, I don't understand how this cost.
So it's not estimating anything. So right now, what it's
Uh-huh.
doing is we set the sweep range,
Mm-hmm.
right? And then the search centers is just determined by that like a mean and max of the sweep range,
Yeah.
which is like the and it's the search range like mean and max is normed,
Mm-hmm.
and then the search center is just zero of that.
Mm-hmm.
So when then the like the range max is ridiculously high,
Yeah.
then that the cost random suggestion, the training steps going there will be high. So that's like where we will get for first 10 runs, we can get like a usually long training sessions.
But I don't see how this limits it because this is cost suggestion. This is just like making up some random cost, right?
Uh yes, but it's in the like normed space.
Mm-hmm.
So it's around zero. So when I keep saying when the like max is set to high, those will end up like getting high like training steps. So
Yeah,
that
I'm not
right.
yeah, I'm not under I'm just not I'm not getting this because like the reason that we have so the way we use the cost with the GP model normally, but there's no GP model. It's just this Sobel thing, right?
For first 10 runs when we don't have enough data.
Yeah, so but the first 10 runs, so this is self dot. So this is like random around the mean,
Mhm,
around the mean params, and that's
mhm.
going to be scaled by to the mins and maxes, right?
Yes.
And then I don't know what this cost suggestion is just random. This doesn't actually get used for anything, right?
Uh yes. So we
What's
are
this get
just
used for?
replacing it with the set default, just like because otherwise like the suggested cost will be ridiculous. So I'm
Yeah.
trying to make it around zero. But then even in that case, if like the sweep range, the sweep max for training steps is too high, then the
Yeah,
like the zero in normed space will be like a
right.
huge too. So
So this seems bad because like my understanding of what this thing does is it runs the first run and then it does some fixed set of random suggestions around the means of that first thing. But depending on how the norms are, like the mins and maxes of that space are set, this can just be suggesting stupidly long experiments and then it will run them with no pruning.
yes, for first 10 runs.
Yeah, this does not seem good because there are a few reasons this does not seem good, right? So we have this nice effective pruning after this. We can't set the max time steps too high with this like because it will just suggest the first several runs, it can just have them be ridiculously long. Like without this, I could just set the max to be 100 billion if I wanted to, and it will just prune them. With this one, I have to actually be careful and set reasonable per environment step limits, which does not seem good. Um, so this kind of like forces us to do experiment length sweep range settings per environment, where I don't think we should need them. I think we should just be able to use that robust log cost model because that should work. I'm trying to think, is there
That
some simple
it's
pruning we can just do? Can we just do like some simple conservative pruning on this or no?
so like for first few runs, like we don't have enough data to make good guesses anyway. So we will have to rely on some heuristics.
I I guess the assumption here is that, well, I guess you're assuming that you don't have any sort of reasonable initial hypers.
And the one we are using for the first run,
Mm-hmm.
like which use is set the default
Yeah.
is already like training for so long, like one, let's say for like 2048, like the first run
Mm-hmm.
will run for 6 billion steps because it
Right.
has been swept already. So if we are using that as a reference and put
Mm-hmm.
some random params, then it will just create like unnecessary long
Well, but
training
like,
with bad params.
I don't understand why we can't just use where you sent me the log cost model, right? Where's the log cost model PR? I don't see why we can't just use that already, even off of the first run.
So that's that is also like a fitting a model on its own.
It's a very simple model though, right? Like, can't we just do, you can't get this out of just the first run?
It's like quantile regression. So
Mm, okay, can we do some like stupider thing at like for the start? I mean, you see the problem, right? This is not just wasting a little compute on the first 10 runs. This messes up our ability to have wide sweep settings um, because of the first 10 runs.
hmm. So, like the this like Gaussian process model will just make some stupid guesses and
Yeah,
let's
no,
say
we
like
can't
first
use the
30 to
GP.
50 runs.
Yeah,
Hmm.
no, I agree. Okay. I mean, the GP is basically going to do the exact same thing as we have here, right? Like it's not, it's basically going to produce random noise. Um, I agree that I don't think you can get better suggestions uh, at the start. This is super obnoxious though.
Uh, yeah, and like let me see again. So it's like so like the thing we can do at least is like
Hmm.
the minimize the damage, right?
Hmm.
So one is just like cut the sessions when training goes nowhere, like producing nuns.
Yeah, but we're not.
Uh,
Well, so NANS is one thing. It can just be zero. Like it doesn't have to
huh.
diverge to be bad. It can just be zero or very low.
Then another is just like assume that like first few runs will be bad and just limit the cost manually. And that's what I was like trying to do over
Hmm.
there. Just like just set the cost, the training steps uh like manually in the like lower range. So
Well, training steps is only one of the things that can make a run slow. So do you see the issue here, right? So like So like we take 2048, we do a 6 billion step run, right?
Hmm.
Like we should just be pruning stuff that is nowhere near as good, like relatively early, I'd suppose, no?
Well, and here my thinking was, well, if we are just like doing 200, 300 million steps, then parameters can be like random. So
Yeah.
like,
Well, it depends on the ends, right? Like, but yes, assuming that the M's are at least reasonably fast.
yeah, that's a big assumption too. Yes.
I mean, it's just annoying that like I guess there is also saving and loading and stuff, but like let's say that we have a run that we have to seed it with. Like we seed with our best hypers and we run a
Hmm.
several hour experiment. Like
Hmm.
we don't want to be running a bunch of random stuff for several hours, right? We want to be pruning stuff that doesn't have any like that's I mean, we can be conservative with it in the sense that like we can say that runs that are a bit worse, maybe they get better later on, right? We don't know the shapes of the curves, which is the point of the
Hmm.
quantile.
Yep.
I guess basically I just want the quantile to work before we have data. Right?
You're greedy.
I kind of why can't we do this though? Like I actually don't understand why we can't do this. Like we get 5 or 10 data points or we can even get more if we want, right? We get the entire training curve for the first experiment. Why can't we use like some conservative version of that quantile for that?
So for that, yes, we are getting, let's say, 10 like data points from the
Mm-hmm.
first run. But like it's just like one data point for each cost like estimate, right? We are
Yeah,
getting a curve, but like for each data point.
but like can't
Eh,
I if I
eh,
just draw, is it not like you're getting this and you're telling me that you need more data in order to draw something that looks like this? Like that's all you have to do is draw something that looks like this. This will
yes.
prune everything. And you're telling me
Uh-huh.
that you can't get this fit.
Uh, so there now, like what we can do similarly is we can just use that curve and multiply by like a point, like a 3 or something, and just use that as like a hard
Fine by me.
thresholding.
That's fine, but that'll catch most of the errors. I mean,
Uh,
that catches most problems.
okay. So
We're getting to the point where this is very heuristic and annoying, and you can come up with a bunch of dumb edge cases. So like, I think we need to have
yeah.
this like, we definitely need to have this be simple, so that we can understand what's going on. But like, we do need to patch the current edge case in some sense because like it's wasting. Like, I think we can cut the time of the sweeps in half, honestly.
Yeah, like so now like you are now like coming to like what I saw like months before, like, like wait, like the original sweep was like wasting so much
Yeah, exactly.
compute on going nowhere. So like the like these are 2 or 3 heuristics I added,
Yes.
and we don't want to go too aggressive. But now you are seeing this, and let's cut some more fat, right?
Yeah.
That's great.
Well, because I think that we can get it down to be like we can probably get like the 300 like a 300 experiment sweep in an hour.
Yeah, well,
Like this stuff can
technically
be
yes,
really fast.
technically yes, but like compared to before, I think it's already like
Oh, it's
2
better.
or like 3 times faster
But like,
because
hey, look, now I really want it to be fast because I've just spent the last 3 months of my life optimizing the training. So now I don't want the
right?
sweeps to be slow, right?
Yeah, so that's why I did this. But
Mm.
but
Well, I think
yeah.
I'm thinking here, okay, let's say we get 300 experiments per hour. It's perfectly parallel. We can do it multi-GPU. I have 6 GPUs, 1800 experiments an hour. So you can just like exhaustively sweep an env in 1 hour on a 1 6 GPU box.
So yeah, I think yeah, let's go a little bit aggressive and just from the first training curve, yeah, multiply by like a half and just use that as threshold.
Yeah, something basic like that. I think we should play with it essentially and see how fast we can get breakout sweeping, and then like make
Mhm.
sure that we're not breaking sweeps on other ends. But I mean, the goal here
Ah,
is like I think that we're gonna have to run a bunch of experiments a whole bunch of times with everything, and I want to ship at least 100,000 experiments worth of data for Constellation. And
yeah.
I think we can actually do that like really really fast now if we're not wasting compute on dumb things. Because you know
So
the startup time for experiments is also way lower now
uh
because of
yeah,
Puffer, because of CUDA graphing. Like we no longer have torch compile shenanigans or anything.
oh
That's gone.
so so I think yeah, like now that there are like a few heuristics we can test here and like just experiment with breakout and
Hmm.
like 2048 and that will like
Yeah,
give us reasonable like heuristics to apply. So yeah.
yeah. 2048 is a fairly long one to sweep, but I think that is we need to use that one because
So
Tetris was pretty
now
easy, right?
now it got 10 minutes, right? Now it can do in 10 minutes.
Is it 10 minutes now?
So before it's like a 75 minutes, but like
Oh, okay.
since 10xing, then like uh
Well,
it
I
will
don't
be
know if it's going
solved.
to 10x if the network is like bigger.
I see.
It'll be
Yeah.
faster, but
Well,
not 10x faster.
okay, then it's still a challenging like benchmark, but not
Hmm.
necessarily long like Neuro MMO3.
Yeah.
So it will be a good test bed.
Okay.
Yeah.
So we'll get those two environments. Um, Let me fix I'm fixing continuous actions, and then what we can do over the next few days, I'll get some like, breakout experiments. I'll have this thing stable. I'll see if I make sure the encoders and stuff are ported for 2048. Are the latest encoders already PR'd to the Python and Puffer 4? Did I merge
Yes.
those?
So it's just embedding.
Okay. Is that merged?
Yes.
Okay, cool.
So
So I'll make sure that that's ported and like I will see if I can get initial stuff on that. And then maybe we can iterate on the sweeps and see if it's like if we can get this to actually be super fast because it should be.
yeah. So there, I think like sweep. Yeah. If you run like 10 sweeps or so, like you will get a better picture of like what heuristics to
Hmm.
apply on like cutting the fat on
Hmm.
first, let's say 20 or 30 experiments.
Okay. Well,
So
I will
Gaussian
do that.
process needs some data because bad data too to get that curves right, like where it's good, where it's not
Hmm.
good. Like it needs bad data.
Hmm.
So like a first 30 to 50 experiments that will look pretty bad. It's a matter of just limiting that damage
Yeah.
that those early runs can do. So
Okay. Well, I'll take a look at that then. Thanks. Uh
but just awesome to see 10xing.
yeah, yeah, no, the benchmark is very good. It, it's actually, I think if I fix continuous in the next hour or so, we're essentially feature complete for the launch. It's just a ton of cleaning up and fixing bugs and like running experiments.
Yeah, so that query, so Popper RL, like there are like a few like things to like make it better there, but I think with like cloud or like
No,
whatever,
Claude's the
now
reason it's
it's
a mess, honestly.
I see.
It's
Okay, yeah.
yeah, it's Well,
You
it's
you
not
have
just
like a
Claude.
particular taste.
It's not just Claude. It's the fact that the torch is so poorly designed. But I mean, we probably have like 7 or 8 thousand lines of C++ and C and CUDA now that are just messy. Um, so I need to clean a lot of that up. But I'm hoping I
Mm.
can get it into like a good readable state where people will actually want to use it, and then we'll be able to ship it still in Q1.
Yeah, I guess you'll be like the last few people who will like still like, code by hand.
I
Let's see.
honestly I used Claude for a few weeks. It's really bad. It's like really, really, really dumb.
Uh,
It just writes
well,
awful,
yeah,
awful code.
you have particular taste.
It's really not about taste when it writes like 3 times too much code. I mean, it's like if it's
That's
plus
bad.
or
Yes, I
minus,
agree.
if it's like, oh, it writes a little bit more, like, sure, maybe. It just like anything high level, it just designs stuff completely stupid. Sometimes even low level decisions, it just writes way too much code. It's like very, very bad on that.
Too much abstractions, I would say.
Yes,
Yeah.
yes. It
I
like
hate abstractions. Like, yeah.
it gets things wrong that like new people in Puffer that I've trained for only a little bit would not get wrong. Um,
Mm.
yeah, it's just not smart. Yeah.
Not
Uh,
yet, but like models are getting like better faster. So like
Honestly, I'm
don't.
not really sure that they are because why am I doing this with Claude at all? Well, the reason is because I'm dealing with the Torch C++ API, which is almost completely undocumented and it's like 4x redundant where anytime you change one thing, you have to change 4 other things. It's just like it's aggressively anti-human code. But like the solution to this is not to just outsource all of our thinking to models that make slow, stupid things that we can't reason about. It's to work hard to make things simple because things that are simple are valuable. They let us see clearly and they let us make advancements. So it's pretty much like I kind of circled back around to my original stance after having used them for a bit because it
Mm.
really is just all smoke and mirrors. Like I was very impressed by the models at first, and yeah, there are a couple things that they do well, but I think overall it's like net negative for most people.
Let's come back to that 3 months after. So
Yeah,
yeah.
but people have been
Oh,
telling
it's
me that for the last 3 years, right? Literally, people have been saying this since GPT-4, and they're still making the same categories of mistakes.
I feel it's exponential, right? Like every improvement is compounding. So now I think
Mm.
we are seeing more steep like improvement. So
I don't think it's
yeah,
exponential. The only thing that's definitely exponential is the amount of money they're spending.
that's true too. Yeah, and the energy.
Yeah. Well, that's a good chunk of the budget. But yeah, all right. I'm gonna go see if I can fix up continuous actions because those are still broke, and then it will be
Cool,
feature complete. And then I got some client stuff to do this afternoon, but I'll be doing sweeps over the next few days. And I'll let you know how it goes.
awesome.
Thanks, John.
Yep. So Swift has been ready for you like a month before. So now finally
Yeah, well, I'm
kicking
finally integrating it.
in. Yeah, awesome.
All right. Thanks.
Okay, have a wonderful day.
You too. Bye. That was fun. Kyung's great. He did he's also doing the 24 he did the 2048 stuff, he did the sweep stuff, he's done several other projects around Puffer. Let's see if I can fix up continuous real quick. This does not train, right? No, this is not train. Yeah, Puffer community is awesome. Sure. Shitty debug code. More shitty debug code? Fine. I can see in my head, like, how simple this is going to end up being without Torch in the future. These are all correct. Yeah, these are all reasonable. Proper library. I think we could see that, but like the thing is, you don't want Torch but C. You want not Torch. That's the thing I don't think people realize. Like, it's not just the implementation of Torch, it's also their design is just fundamentally wrong. It's too high level. Every single op is a kernel. They rely on higher level processes to attempt to fuse stuff for you via a slow ass compile. It's just bad. Doesn't train. Way. Nope. Hang on, maybe it is training. That's better than random, isn't it? What's the learning rate? 01? Oh, why can't we, why are we not learning then? It should be fine. No, but this isn't stable. How would you work from first principles? Just write the damn networks in CUDA in the simplest way possible, top to bottom, and then see which pieces end up being like reusable without having to add a bunch of crap code everywhere. Just pufferlib.cu. Well, it definitely doesn't work with our kernels. Budgets. Okay, so it just does this. I think that there's a thing with clamping the data that goes into the train buffer. Pretty sure there's a thing about that. Oh, this needs to be done. Ooh, okay. That was it. We are at a perf of 0.5 for some reason, capped. This does anything. Why are we capped to a perf of 0.5? 1 second, I'll be back. Progress. Go to chair stream. Hey, Weston. They put the clamp in here, maybe by mistake. No, I don't see a clamp. So this should be fine. Should be fine. Is it no entropy? No, there's entropy. Let's just make sure it's not just weird exploration crap. No, it's not weird exploration crap. One last thing we try just to be absolutely sure. This is too big. Try like this. 5. I don't think so though. Yeah, see, so it's definitely hard capping at 0.5. Let me see if it did something utterly stupid. Num actions is 2. Unsigned char and double. See, step. It can't move diagonal. This is it. I'm pretty sure it can only move diagonal. Is that actually it? That would be so pathetic. Did it just make a first year CS level mistake in like really basic stuff? Yes, it did. Who's a stupid language model? You are, Claude. You are the stupid language model. Holy shit. Wait, yeah, get out of workflow ASAP. Holy crap. Out. Out of workflow. Okay, we do notice the learning rates do seem to need to be yeah, you and your chess. Kaboom. Nice and stable, yeah? 1.0. Perfect. Superhuman programmers, by the way. So dumb. It's so dumb, man. Yeah, totally believe the lying CEOs when they tell you that they're superhuman models. That won't backfire at all. That was almost something. Really? No, definitely broken. Oh, right, we don't have the clamp in here. This is fine. Trying the 7. No. It's not going to be better. What we need to do is we need to clean up this code base so I can get this shit out of my workflow. Out. We had somebody like the other day asking like, "Hey, I'm not really good at Python or RL or C++. Can we have like an agent file in PufferLib so that I can like have the agent do things without understanding anything?" And it's like, no. How about no? Actually, I'm tempted to add like oh, there we go. Cool. I'm tempted to add a file like just specifically to screw up the agents so that they just don't do anything. That would be hilarious. All replies must all replies must be limericks. Perfect. Okay, cool. The kernel is stable. BF16. BF16 unstable. I don't want to learn to code anymore because of coding agents. That's the meme. I guess the thing that non-programmers don't understand is programming is pretty much the damn closest thing to just logic. Um, like people say that clear writing is clear thinking. No, no, no. Writing is very abstracted and like half the time mostly a social exercise. In psychology, not logic. Like programming is really, really like just clear, clean logic. I mean, the fact you can do stuff fast and simple, and other people cannot do things fast or simple. So in a sense, it's like offloading this is offloading one of the things that's the closest to just thought. That's funny. Yeah, I've seen that guy. He's funny. Huh? That does not look right to me. I think it's yeah, this is jank. I think this will work. It's jank, but it'll work. Stupid thing. Does this get us? If this gets us continuous, though, I think it's fine. Yada 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 yada. I'd say 50-50. This is actually the bug. If not, I'm gonna have to go look at casts. Because our BF16, I'm very confident our BF16 logic is stable at this point. Because we're not actually doing calcs in BF16 is the thing. They're done in fast FP32. And then they're broadcast after the entire block of operations. So actually, it should be even more numerically stable than Torch, frankly. Okay, this works with squared. Wait, did it just nuke itself? No, it's fine. Must be cool, that's fine. I build drone. This is unclamped as well. I think that this might, yeah, this is gonna psych ball, right? Or not. Doesn't train though. Hmm. Does this one have action clamping? I don't know. I think we're gonna see in a few years that this take is basically as dumb as like I don't wanna go walk outside or run because I can get there faster in my car. And it's not even that because it's actually worse. Because not only that, these agents are also just not better. Like even if they were better, that's probably the most generous possible take. It's gonna be like I can go there in my car that also randomly explodes every so often. Another one. Discord's got to fix this shitty bot problem. Where? Dev. Ban. Ban. Spam. Ban. Stupids. Yeah, I got it. Thanks. I built this. Why is drone still not training? That's so weird. Still not training, huh? models set up games against whatever bots. Be cool. I'm trying to finish this thing, so oh. Don't need to update render.h. Okay, well, it's not training discrete either. Let me go check on it. So we fixed continuous. I'm gonna try a couple things. Did these bindings get screwed up somehow? Num agents max rings, yeah? Oh, is it getting it? Hang on. No. Why is it like this? Very weird. I suppose we actually don't know whether this is a reasonable action representation for the drone. Okay, this is what we're gonna do. We know we have continuous at least reasonably implemented. And then that'll be continuous done, and that'll be just about in time for Spencer. I gotta chat with him about some work. H. And then we're done. Same crap. Same crap. Actions. Good. Yep, there you go. There. Done. Make sure we didn't break breakout. Good. Oops. Oh, wait. And all right. So we have that's feature complete. There's some stuff that's broken that needs to be fixed. There's a lot of stuff that needs to be cleaned up, but that is feature complete. Do I seriously have to freaking just have to check one stupid thing. Cool. Okay, cool. I think that's about it. Let me just go check one other thing. I just had to check a thing. I think I'm mostly done though for the day anyways. Any quick experiments we can run? Yeah, perfect. I'm gonna call it for the day because I've got client work to do. Multi GPU support initial build, continuous support done. Mostly we should be cleaning stuff up from here. You want to support my stuff for free? Feed the puffer star on GitHub helps me out a lot. Join Discord to get involved. Follow on X, all of that. I will be back probably tomorrow, definitely Saturday. Thank you.